A rope of negligible mass supports a block that weighs 30 newtons as shown below. The breaking strength of the rope is 50 newtons. What is the largest acceleration that can be given to the block by pulling up on it with the rope without actually breaking the rope? So here's the figure that shows what it looks like. So if we quickly draw a free body diagram, let's say that the rope is pulling on it with the maximum possible tension before it breaks. So I'm going to call this T max. So that's the maximum tension of 50 newtons, and any more than this and the rope will break. So T max. And opposing that we have its weight. Its weight here. But it's actually accelerating up. So we have an acceleration up. Net acceleration that is upwards, because the tension force will be greater than the weight force. So now let's write an equation based on this. We can say that the max tension minus the weight force must be equal to the mass times the maximum possible acceleration, because getting a higher acceleration would require more force. So these are the net forces. So I can just simply say that the summation of all of the forces will do that. So now we can plug almost everything in, except we don't know what mass is yet. So we know that the weight of an object is given by its mass times the acceleration due to gravity. So mass is equal to the weight divided by gravity. So we can substitute that in. So we can say that the max acceleration is equal to the max tension minus the weight divided by the mass. Or we can replace that with the weight force divided by the gravitational acceleration, which simply becomes this expression. So the maximum acceleration is equal to the maximum tension of the rope minus the weight of the object times the gravitational acceleration of 9.8 meters per second squared divided by the weight of the object. So all we need to do now is plug all the numbers in. Max tension of 50 newtons, weight of 30 newtons times the acceleration of 9.8 divided by the weight of 30 newtons. And now if you solve this, you should get that the max acceleration is going to be about 6.5 meters per second squared. And that is how you would solve this problem here.